Among the 8 planets in our solar system, Venus is Earth's closest neighbor. On a cosmic scale, it lies an average of 41 million kilometers from Earth. With current technology, a spacecraft takes about 4 to 6 months to reach it. Venus has a size and mass remarkably similar to Earth's, with a diameter only about 5% smaller than our planet. This resemblance earns Venus the title of Earth's twin planet. Yet, despite its proximity and similarities, Venus is not a priority for human exploration. Instead, we focus on Mars and the moons of Jupiter. So, the question arises, why haven't humans landed on Venus? In fact, humanity's exploration of Venus is not uncharted territory. From 1961 to 1985, the Soviet Union launched the Venera program, a series of missions to explore Venus. Over more than 2 decades, the Soviets sent 28 probes as part of this initiative. Their goal was to unveil the mysteries of this enigmatic planet. However, these probes faced immense challenges. Upon reaching Venus, many failed or lost contact shortly after landing. Only a few, like Venera 13 and 14, successfully transmitted images of Venus's surface. Among them, Venera 13 set a record, operating for 127 minutes before succumbing to the harsh conditions. So why did these probes fail on Venus? The answer lies in Venus's extreme environment. Let's view it from a probe's perspective to understand the challenges of reaching Venus. First, a probe must navigate a thick atmosphere rich in CO2 and sulfur. Clouds of sulfuric acid envelop the planet, stretching 20 to 30 kilometers with intense corrosive power. This acid can destroy most metal components. The acid clouds alone pose a formidable barrier. If a probe survives this layer, it faces terrifying winds at altitudes of 50 to 70 kilometers. Wind speeds reach up to 360 kilometers per hour, 3 times stronger than Earth's most powerful hurricanes. These winds can destabilize or destroy a probe. If a probe miraculously lands on Venus's surface, even greater challenges await. Surface temperatures average 464 degrees Celsius, hot enough to melt lead and ruin electronics. This makes Venus the hottest planet in our solar system, its surface resembling a colossal furnace. Probes are often cooked upon arrival. Additionally, atmospheric pressure is 92 times greater than Earth's, equivalent to the pressure 900 meters below Earth's oceans. This can crush a probe. Lightning on Venus adds another threat, with strikes lasting minutes, compared to microseconds on Earth. These conditions turn Venus into a veritable hellscape. As a result, humanity paused efforts to land on Venus. Instead, we turned to Mars and Jupiter's moons, where environments are more accessible. It's not that humans lack interest in Venus, but current technology cannot overcome the planet's extreme conditions. Moreover, studying Venus yields less immediate value compared to other targets like Mars. Venus's hellish environment makes life unlikely, and the resources required to land there could be better used elsewhere. For instance, Mars holds potential for supporting life and future colonies. Our moon, too, is more accessible for study. Still, Venus offers clues about planetary evolution. Understanding its past helps us learn about Earth's climate journey. Despite its challenges, we haven't abandoned Venus. After a hiatus since the 1980s, new missions have been launched. Radar and spectroscopy technologies map Venus's geology and atmosphere. In the past decade, NASA and ESA planned missions like Veritas and Envision. In 2020, scientists detected phosphine in Venus's clouds, a compound possibly linked to biological activity, though this remains debated. These findings reignited interest in Venus. Billions of years ago, Venus was likely very different. Models suggest it once had oceans, a temperate climate, and tectonic activity. Like earlier, it may have been hospitable to life. So, what transformed Venus into its current state? Scientists believe a catastrophic event occurred about 700 million years ago. Massive volcanic activity resurfaced Venus. Widespread eruptions released vast amounts of CO2 into the atmosphere. A runaway greenhouse effect caused all liquid water to evaporate. The atmosphere grew dense and stifling. Over time, Venus became the high-temperature, high-pressure planet we see today. This process, known as a runaway greenhouse effect, serves as a warning for Earth. Venus illustrates the dangers of unchecked climate change. Though Venus isn't a feasible landing target now, it remains a critical subject for scientific study. More than that, Venus is a mirror, reflecting Earth's potential future. Its transformation was driven by soaring CO2 levels. Earth faces a growing greenhouse effect today. Thus, Venus urges us to act now. If we fail to curb carbon emissions, Earth could follow Venus's path. Venus is more than a neighboring planet. It's a stark warning. We must protect our blue planet before it's too late.